This is the first important thing. If you notice in the bottom of my bio, I'm really good at breaking people's demos. So I apologize for anyone who went before me or anyone who goes after if you're doing a live demo. I likely am going to be the person who breaks it just because I'm here. It's one of my superpowers. The question I was asking earlier is, who here uses local large language models? Okay, there's a couple of you. Have any of you discovered how many is too many to be running on your computer? This is how many I have on mine. It may be too many. But it's important, right? Because everyone right now, we're talking about these models, they all behave differently. Claude behaves differently from ChatGPT, which behaves differently than Gemini, which behaves differently than whatever other model you're going to find. So this is interesting to go work with them to go see what you can go do to learn about these. But then the really hard problem becomes, how do I maintain my data security and provenance? I can do that through my contracting with what I do in the cloud, with who my relationship with my hyperscaler is, or I can do the really hard thing and run it all the way at the edge, either in my computer or in my data center. And what you'll learn is when you try and do agentic workflows with local models on your computer, it mysteriously, what worked with Claude doesn't work anymore. I may have learned that the hard way. I'm going to just do a couple of definitions here because usually when I'm giving this presentation is not to a group as technical here, but just to make sure I level set. When I talk about AI, I break that into two different spaces. There's generative AI, which is LLMs and anything probabilistic or non-deterministic. And then there's conventional machine learning, which is consistent, repeatable, and I can prove why it's working. And the reason I differentiate those things is the number of times someone asked me to go make a large language model consistent and repeatable, I've lost track, but I know I can't do it. And then when we talk about Internet of Things, this is anything now, might be even an Intel NUC. It's something I'm running at the edge. It is not in the data center, and I may have dozens or hundreds of them deployed or thousands. Yep, I said Gen AI. You're going to learn here. I have some bad habits of playing with what the AI music generation tools are. And so one of the things that we figured out here is this is what you could do with AI music in 2023.
Woke up this morning, sunlight's going in the heartland with.
It's not great. It's okay. 2024, it's better.
Woke up this morning, sunlight's going in the.
It's better, but it hadn't gotten to the AI generated hit. But if I go play with the newest model today, which is a company called Sonata.
Chicken coop cacophony. Oh, can't you see we're clocking out for freedom? Just wanna be.
It's awesome.
Chicken coop cacophony. Oh.
There we go. I'll put that on mute. The backstory is one of my teams was in a very long Slack meeting or a team end of sprint demo. It'd probably been going on for an hour and a half. You've all been there where things go a little off the rails and people start messaging. And someone heard chickens in someone else's background. And all of a sudden there was it turned into a potential for the Colonel and the Chicken Smugglers, which is we've determined our virtual hardcore vegan band. So if I can go here to the next one.
You need to move closer.
I'll grab it after this. And let me just do one more. Cool.
I think it's gonna.
Yeah, I'll pick it up after this. I'll do one more demo. And now, not only can you do the video or the audio, but you can do some pretty good image video.
Chicken coop cacophony. Oh, can't you see we're clocking out for freedom?
And what I learned with this, by the way, beaks are really hard to get it to do. If I had just done a human character, it would have been fine. But this, there, I'll hold it there. But the beaks were a problem. But that's an ADD break. Let me just continue going through. So as my team has been working on this, we do a lot, as I said, at the edge and in the cloud as well. So we love Kubernetes and do a ton of scaling and automation with that. But we also do a lot with conventional IoT and machine learning. So when you start pushing all this to the edge, now you start to go, how do I speed up the decision-making? How do I speed up the scale? How do I increase the scalability? And then what do I do with all this data I'm generating from the system? So when we look at this, we're using Kubernetes to power the backends of our systems. And actually we're pushing this all the way to the edge. And when we're using Kubernetes, we're using it for the cloud, We're also using it for our machine learning workloads. And I'll talk about a use case of one of those in a second. But so now I have that machine learning model. How do I get that out to the edge? Or if I'm using that local large language model, how do I get that distributed? We also use a lot of serverless, so that way we can build the scalability in. And then we tend to use a lot of hybrid work with the edge and the cloud. And sometimes what we're doing there is we're making a decision on the edge to say, hey, this requires too much processing to do here. So I'm going to send that to the cloud where I can do it faster and then bring the answer back. And then we've got to build all the secure pipelines and everything. So when we look at this, as I go through some of these real life case studies, and by the way, you guys are getting a CEO, you're not getting the technical programmer, so you're not going to see a ton of demos here from me that are down at the code level, which you guys will be grateful for, because if you saw my programming, I would not pass the test. But my team does a lot of work in life science and finance, and we do a lot in conventional manufacturing as well. And so as we think about these, all bring different challenges as we build them. So this is a project that we did that was really just a chatbot, but we learned a lot from how do we build the back end to scale, and also what are some of the things you have to think about from a security perspective. This was working around clinical research trial data. And here I'm just going to ask it a question about a specific thing and use this to drill in. So this is a deep research agent, if you want to think about it like that. And as we were going through this, we learned some security things, right? We were talking about they were using the term prompt guarding earlier. Okay, prompt guarding is really important, but how often is it that you're protecting against a true security thing versus, I'll use the term, a reputational security risk. So reputational security risk is it needs to respond in a certain way, or it needs to not do certain things. I.e., if I'm giving a summary of a study on cancer, should I have it give that back to me in the lyrics of a song or a poem? Yes, a user might ask that, but is that really a response I want? Or does that create other things? So we had to learn how to build all of that security in. The other thing is you build these kind of tools that you learn is AI is not great about generative AI is not great about keeping things in order. It's really good about knowing a whole bunch of data, but it doesn't always know the relationships. So you may hear the term graph RAG, which is one way to go solve that, where you're building a graph from the data. There's another tool. I always mix it up with the Google search algorithm. So I believe it's Page Index is another vector tool that keeps the relationship of these. But how do you keep the relationship of the data and the sequence is super, super important in some use cases. If I'm generating text, it doesn't matter. If I'm looking at data or looking at reports or certain things, I need to keep all that in order so I can give that consistent answer. Or if I'm dealing with multi-tiered tables or other things. So as you're working through, you need to start thinking about what are the right tools to achieve the business outcome I'm trying to do. So it's not just throw the cool, shiniest technology at it. There actually has to be a real business reason that we're going to provide value with. So back to conventional machine learning. This is a real deployment of ours. If you are going through the Raleigh-Durham Airport, or you go through LAX or DFW, you'll see these, or Nashville now, actually. These are a product that we helped a customer of ours build. It looks like a locker, and basically imagine if you were placing your order ahead of time. You can go get your order out of this device. It will know when you pick it up. It knows how long it sits, and make sure only the right person gets it. For those of you who've been at Starbucks and you've seen I'll just call it the mosh pit at the end of a Starbucks for their mobile pickup, this kind of solves that problem. But since each device has at least 7 cameras, some of them have up to 30, how do I go distribute the machine learning models and keep them all updated for all? That was the problem we had to solve here. And this required a custom machine learning model. There wasn't one off the shelf we could run in the performance envelope that we could use. When I talk about performance envelope, the amount of compute and memory I had at the edge. So we built this. There are tens of thousands of them. We've got some of these at locations that are doing 4,000 plus orders a day through one system. So you think about that from a machine learning cycle and dealing with human interactions. But the other thing we were doing with this is we're using Kubernetes at both the cloud and the edge. So we can move workloads from the cloud to the edge and back. You learn a lot about what doesn't work with Kubernetes mesh networking in that one, is what I'll say. This is where we're very excited about some of the new AI SRE tools that are coming out. So you can maybe trace and figure out what's going wrong faster, because you get some really weird things on networks you don't control. As we think about automation and we think about all this, you've got to be approaching this from a security first perspective. It starts with in our world, the IoT security, because we do so much at the edge. So how do I physically secure the device? How do I make sure it's encrypted? How do I make sure if someone gets access to it, it doesn't go off the rails? When you're dealing with the cloud, you don't have to think about physical access, which is a nice thing, but you still should. And then once you're getting data between the device and the cloud, how am I making sure that's secure? How am I authenticating? How am I working through all that? When someone is saying, hey, we need a specific solution here, this is what I mentioned earlier, right? We got to make sure that the technology matches the business problem. And in some of the cases that we deal with, this gets amplified by regulatory complexity. Depending on where you are and what kind of customer base you're dealing with, you may have scenarios where you've got to maintain data sovereignty, keep data within a specific area. You may have data you've got to go work on from a PII or from a HIPAA perspective. Those are privacy regulations in the US. You may have GDPR. There's a whole bunch of different ones in Canada that you have to deal with. In the US, we've got some weird privacy stuff here that goes state by state with California and Colorado and a couple of the other states. So those are all things you have to think about when you're designing these systems, particularly from a machine learning or a generative AI, because I scale up the amount of data I'm dealing with, I scale those problems up and some of those risks as well. And then once you start moving into a generative AI perspective, now it's how do I deal with hallucinations and how do I deal with the reputation risk? And then there's a third one here I should have put in that I mentioned a couple of conversations, but how do I actually secure it? LLMs are really fun, but we've taken every piece of social engineering you can do to a person, and now we've built it into software that no one really understands how it works. I just want to reiterate that from a security perspective, right? That's something you got to think about. A couple of examples of some of that stuff I've seen. If you guys remember when DeepSeek first released the 1.5 or whatever their first model was about a year ago, everyone was really concerned about what it said about Taiwan or what it didn't say, right? If you ran it in the cloud, you got one set of answers. If you ran it local, you got a different set of answers. If you ask it questions in German, it didn't pay attention to any of those safeguards because it was trained in English and Chinese. So things you've got to think about how hard it is to defend if you can come at it from a different language or a different angle and ask those questions. And so now we're taking those tools and using those to power all kinds of things. So what does that mean? Is this the equivalent of putting the percent sign back in SQL? For those of you who remember early SQL injection attacks, and we don't have answers for some of that. The other thing we've got to think about is cost, right? These tokens aren't free. And when they introduce a new model, sometimes the tokens get a lot more expensive. So how are we efficient? How are we using the right one? Some of that in my team, what we're seeing is we're doing more things where, whether you want to call it a gateway or a router of some form, where we're using different models for different pieces. So you may use a local model for some things, and then you use a frontier model for other things, either based on data risk or just based on cost or the fact that I've really heavily fine-tuned the local model. Those are all architectural things that you need to go think about. As I was talking about the security piece, this is one I think we can't say enough right now. It's with generative AI and with machine learning, it's moving so fast. There's a lot of things that get overlooked or brushed over, and they can create some challenges, right? So think about with GDPR, you have a right to be forgotten. This is something that early blockchain stuff ran into too. But if I now have this trained into a 1 billion parameter model or a 1 trillion parameter model, how do I make sure I've removed that specific person's data and I can do it provably for them? Stuff we got to think about. It's an argument in some cases, maybe you're better off using a RAG or something where you are not putting it directly into the large language model for that specific reason. How do you deal with all your compliance frameworks? I've got HIPAA, GDPR, SOC 2 up here, but you could go to NIST 800. You lose track, right? Every time you turn around, there's a new standard that some group has to go comply with. But how are you dealing with all that? I talked a little bit about reputation risk, but with the AI, we were talking earlier about Anthropic and some of their decisions. Different AIs are trained in different ways. They will respond in different ways. Does that create a potential risk for building in unintended bias into what your system is doing? So think about if I'm using this for a analysis of medical records and there's an unintended bias there, whether it's for gender or for culture or for race, and how it responds, that could impact the effectiveness of that on how it analyzes people's records. I was talking earlier with someone and they were asking about using standard test suites. How do I have a standard test suite for that if I don't always know what the problem I'm trying to prevent is? Because I know it's there, I just don't know exactly what it is. That's where I think Tim had a great thing there about Ghostbusters, right? Sometimes that's what we're dealing with the tech. It's interesting. And then as we think about this from a scalability and reliability perspective, how do you deal with this? I've built it all around OpenAI, and I get told for whatever reason I can no longer use it. It's not available in the country I'm in. It's not available because of the kind of companies I'm doing business with. How do I easily switch that? And what does that mean? Does that break all my prompts? Does that break how my system responds? How do I go manage that? When I first put this slide together, I was actually thinking of just cloud to cloud Kubernetes. For those of you who are in the SRE space, moving from AKS to EKS to RKE2, you can do it, but it requires some work. They're not all exactly the same. But with the AI providers, it can actually be an even more specific lock-in. Or remember when OpenAI fixed, what was it, 4.440, where they enhanced it so that it was giving better answers, and then all of a sudden everyone's prompts started breaking because those better answers, even though they didn't tell you they gave a new model indicator, it responded differently. And then a gentleman from Groundwork was talking about the latency and performance, right? He's talking about tracking 100,000 different calls in a trace. That impacts user experience, right? That impacts the latency of all these back and forths or how long it takes to go generate this. All things that we've got to think about as we go through. So now I'm going to get to the Q&A because I thought people would have a lot of questions. Yes.
Thank you very much. Really interesting talk. My question for you is like, how do you split in between these IoT devices that send like a regular data, I don't know, temperature for some things that are not that important? What about real-time systems? And what could be a difference if I, let's say, use edge compute with Google Cloud, or if I would rely on Verizon, for example, where network latency, so I need a server close to my warehouse if I have 15 different forklifts.
Yeah.
Do you understand what I mean?
Yeah, I do. So when you think about how do you distribute the edge, some of it depends on the problem. And some of those where latency is really an issue, you try and force the decision-making to the edge. So you're not using the cloud to make the decision, you're using the actual edge to do it. Because think about an autonomous car, right? It has to make most of its decisions, like a high 99% by the vehicle itself. Because if it were going to the cloud, even if it's using 5G, this is my favorite thing. Everyone asks me, is 5G going to change IoT? No. Because there's some stuff I can't overcome physics. It's just, it takes time to move data back and forth. So you look at what is the challenge that you're trying to solve and then say, can I put that in enough compute? And sometimes that means sitting with the engineers and going, I know you don't think you have much memory when you have 16 gigs at the edge, 16 gigs of RAM at the edge. You can solve a lot of problems in that if you really push a team to be efficient. Sometimes it means they have to learn C+ or Rust or something, and they can't just use Python. They get over that eventually, sometimes. So you've got to look at that. And then for other cases, you've got to think about how do I structure it to be async, right? So even if I'm making the decision in the cloud, how do I build things? And this gets to your user interface design. You've got to give people the ability to feel like things are moving, even if you're still waiting for data. And so that just becomes really clever interface design. And this, again, I'm going to be very hand wavy and say, yeah, it's a design problem, and the designers can come after me for it. But you've got to work with both the engineering and the design in those cases.
I just had a quick question about, you mentioned how you were going to be specifying which LLM you're going to be using in certain, whether it makes more sense to use more computation power or more something easier or something that'll go faster.
Yep.
It sounds like a mixture of experts model is what you're describing. I'm just curious if you see that as being the future, or you think people are just going to rely on one LLM to do everything?
So I think you're going to end up with things, whether it's Open Router is a good example of a piece of software, that commercial software that does this, or you end up with your own router to go choose those based on what you're doing. And it's sometimes based on cost, sometimes it's based on risk of the answer. I don't think a single mixture of experts model can do it because it doesn't necessarily, I may not be able to run something with enough parameters at the edge, for example. So I might run, if you hear someone talk about a 1 billion parameter or a 1 trillion parameter, that's the number of nodes in the network, right? Basically for the LLM. So I might be able to run a 1.2, like some of the new liquid models at the edge, super fast, pretty good, but not as good as running Claude,
Right.
which people are saying right now, Claude and OpenAI are, their top models are 750 to 1 trillion parameters.
Mm-hmm.
The biggest other open source stuff you can get is around 750 billion parameters, which would be like a Kimi 2 or a MinMax. So when you look at where you run those, do you have the compute to run it? And then what's the trade-off you're getting for the answers? So that's where I don't think a single MOE can do it. You build the tool that goes and says, hey, low risk call, do it local, high risk call home.
Mark, thank you very much.
That was a great question. It's something I think we're going to find more and more that we have to all work through architecturally to solve.
Thank you very much.
Okay. Oh, do you have one?
And feel free to ask me about AI video too. That wasn't what the presentation was on, but as I said, I've learned how not to animate beaks successfully so far.
So a great talk. First up, from a cloud hyperscalers, every hyperscaler is growing in AI.
Yep.
How, as an enterprise, how do you keep focus on which cloud platform to go deeper in, or you become agnostic?
So we find, because of where our customer base is, this is where you've got to understand the industry you're working in sometimes. They tend to be pretty commonly in either Azure or in AWS. So that means we can focus on those. And the nice thing is both of those organizations have good AI ecosystems, whether you want to use an OpenAI or a Claude model, they have access, or they have access to some of the other models, whether it's a DeepSeek or something, where you can go use that and based on the cost. But for us, it really depends on what is the problem domain in the customer, because there are some like specific medical models like MedGemma that Google has, right? Where we may need to go use that because it's got some specific expertise or training. So we try and be non-biased, but we choose Azure or AWS first if we can.